Welcome everyone to the next iteration of the IITE seminar series. So today our presenter is none other than Simon Levin from Princeton University, and he is going to be talking about some holistic view of ecosystems, the biosphere, complex adaptive systems, and us. So without further ado, Simon, please go ahead.
Thank you. You can hear me?
Yes.
Yes.
Yeah, very good. Well, thanks very much for inviting me. It's good to see a number of old friends and colleagues on, and mostly to meet a lot of new people that I look forward to meeting in person someday when I'm traveling again. So I'm going to talk about ecosystems and the biosphere and more as complex adaptive systems. Those three bullets underneath of it, I'm going to go into in more detail. And I also want to thank the various funding sources that have been funding me. So the essence of this lecture is that more is different. That's not a title I made up. It's one that my colleague, late colleague Phil Anderson, a Nobel laureate, created in this 1972 paper, which I think is something that anybody interested in complex systems should read. And in it, he basically was sending a message to his colleagues in physics, but I think also obviously had molecular biologists and others in mind, that even though you can reduce everything to simple fundamental laws, doesn't mean that if you start from those laws and all the pieces, you could reconstruct the universe that is moving forward. There are lots of things that are not predictable. There are emergent properties. And very similar arguments were made by another Nobel laureate, Francois Jacob, in 1977, and from a very different field in evolution and tinkering, in which he first of all made the point that you have to analyze complex objects at all levels. And then he said, the second point I want to make concerns predictability, which is very much the same point that Phil Anderson made. He said, can you make predictions at one level on the basis of what's known at lower levels? Only to a limited extent. Although we can look backwards, the properties of a system can be explained by the properties of the components. You can't start with those components and predict what's going to happen. There's too much uncertainty, too much new stuff that happens at the new level. There's no way, he said, to reconstruct the universe. So I think that's pretty much the same point. Sustainability of the biosphere is the ultimate global challenge for consilience research. Ed Wilson, the late great biologist, really made similar arguments to some extent to what Anderson and Jacob said. One of his last books was called Consilience, in which he argued that you needed cross-disciplinary interactions to understand the emergent properties of the biosphere. And he collaborated with excellent mathematicians like George Oster and Karina Tarnita and Martin Novak, among others. But he had a mixed relationship with mathematics. In an article that he wrote in the Wall Street Journal, rather controversial, he said, you don't really need to learn mathematics to be a good scientist. You just have to find some mathematicians to do the math for you. And more concerning, he argued that what he called logical positivism, which is the deductive aspects of using mathematics, is more commonly studied in philosophy, like dinosaur fossils are studied in paleontology laboratories to understand the causes of extinction. So, but I'm going to make the argument that math is indeed the unifying discipline for consilience, because it helps us to grapple with complex adaptive systems and the emergence of macroscopic properties, and to relate the reductionistic and holistic perspectives that Jacob and Anderson were talking about in understanding things like scaling and emergence and pattern formation and critical transitions and conflicts between the interests of individuals and the collective good. And those are the things I'm going to emphasize in the lecture. I want to explore the role of mathematical theory in addressing what I would argue is the fundamental issue of our time, namely, how do we achieve a sustainable future for our children and for our grandchildren? So, ecosystems and the biosphere are what are called, in the terminology introduced by John Holland, complex adaptive systems. That means they are heterogeneous collections of individual units, also called agents, that interact with each other on some local scale and evolve, not necessarily genetically, but in a mathematical sense, based on the outcomes of those interactions. But not only ecological systems, but the socioeconomic systems which they are intertwined, and with which therefore my research on ecology has become intertwined in the last several decades. For a biosphere, the fundamental properties are emergent from lower level interactions. Some of the ones that we would be interested in are things like species abundance, distributions, energy flow, nutrient cycling, ecosystem services. All the things we're interested in at the macroscopic level obviously emerge from lower level interactions. In the same way that emergence typifies problems in economics, the relationship between what some economists study, microeconomics, what individuals do, what households do, and the emergent properties of whole economies and financial systems. And so economists are worried about this duality, and obviously ecologists are as well. And whichever system you're looking at, this implies a need to relate phenomena across scales, from, for example, from cells to organisms, to groups of organisms, to ecosystems, and ultimately to coupled social, ecological, and technological systems. And they ask questions like, how robust indeed are the properties of systems? How does the robustness of the macroscopic properties relate to dynamics on finer scales? Are the systems we're interested in at critical points about the transition? And how do we manage the commons across these scales and conflicts of interest between what the individuals want and what would be the social optima? From a mathematical point of view, I'm going to divide this lecture into three parts. First of all, I'll talk briefly about emergence and pattern formation. These are old areas in theoretical biology. And then an area that's received a lot of attention more recently, but still not brand new, robustness and critical transitions of those patterns. And finally, what I think in many ways the most exciting and important area, the problems of cooperation and collective intelligence. So looking at emergence, first of all, sustainability has to focus on the macroscopic features, for example, ecosystem services, while recognizing that control of those is really resting at lower levels of organization. For example, if we boil water to make tea or put gas under pressure, we know that there are potential phase transitions that depend on the many molecules inside, but we don't think about that, or most of us don't, for example, when we're boiling water. But we recognize that this is an emergent property of the interactions of lots of individual agents. In this case, not necessarily heterogeneous, but still, there's a statistical mechanics and thermodynamics that helps us to understand the macroscopic properties. Well, the same thing is true for ecosystems. Forest growth models that Dan Botkin first developed and Hank Schugert followed up, and my colleague Steve Pacala and his colleagues built the individual-based models where they grew individual trees and let them shade each other, disperse their seeds, etc. And from this, you can simulate the growth of forest communities. And in the simulation, the different colors represent different tree types, different species. And you can run simulations and show that the outcomes are in some ways very similar to what we see in real forest. That is, they don't tell you exactly where you're going to find a beech and where you're going to find a maple, etc. But the relative statistical properties of these distributions is fairly well described by these. And this can be extended up to the global level, coupled with general circulation models. Although here you don't attempt to predict even what species will be where, but what kinds of species, where you will find grassland, where you will find forest, where you will find desert, etc. And this fits with the early diagrams, the so-called Holdridge diagram, or the later versions that Bob Whitaker developed. And similar models have been developed for marine systems through the leadership of Mick Follows and his colleagues, the so-called Darwin model, which is a traditional nutrient phytoplankton zooplankton model with uptake of nutrients by the phytoplankton, consumption of the phytoplankton by the zooplankton, and those terms at the beginning, of course, one way of representing the movement of organisms and nutrients in the ocean. But again, although these do a very good job of predicting where you're going to see particular types of organisms, where you're going to find diatoms, for example, it doesn't attempt to predict exactly what species will be where. So when taking a step back, one has to take a broader view and understand what properties are emergent and what details one cannot expect to be able to predict at the global level. Pattern formation has been one of the central themes of mathematical biology. My colleague who lives here in Princeton, Jim Murray, wrote this book that most of you, maybe all of you, are familiar with. Excellent book from many years ago, and a later version that came out still many years ago, basically extending some of the ideas of Alan Turing in how pattern would arise in a homogeneous space without any external information other than gravity. So there's been a lot of interest in that, obviously, in the theoretical biology literature and more broadly in theoretical chemistry, et cetera, and how the interaction of an activator or an inhibitor could give rise endogenously to pattern, and on top of other mechanisms which may involve the geometry of the region in multiple stable states, can give you a whole catalog of ways pattern can form. But pattern can be fragile, which takes me to the second part of the lecture. I've talked about emergence and pattern formation, but also I'd like to now turn attention to the robustness of those pattern and problems of critical transitions. Stock markets can crash, but they can also recover, and there are critical transitions everywhere we look. There are epileptic seizures, there are migraine headaches, there's atrial fibrillation. We see them in all of our physiological systems. We see them in our societies as well. And if you're interested in this topic, I recommend Martin Scheffer's excellent book on critical transitions in nature and society of about a decade ago, I guess now. One of the questions that Scheffer raises is whether there are early warning signals of these critical transitions. And a lot of emphasis in the work he has led is on a particular class of early warning signals, namely critical slowing down. We come back to that critical slowing down and things associated with it, like increased variance, increased autocorrelation, and maybe flickering between states. But it's important to remember, although I think this is a very exciting area, that not all critical transitions will show these early warning signals. Carl Boediger, Noam Ross, and Alan Hastings have a series of papers in which they explore early warning signals and show the caution that must be exercised. And we've been spending a lot of time here on that. We just ran a meeting on critical transitions. In physical systems, phase transitions provide a model, like the Ising model, for how a critical transition can take place. But in phase transitions in physics and physical chemistry can be divided into especially first and second order phase transitions. And it's the second order phase transitions that show these signals like critical slowing down. So many of the early warning indicators that are suggested are characteristic of second order phase transitions, although the transitions themselves that people are interested in tend in many ways to look more like first order transitions, with sudden transitions rather than gradual ones. So maybe these aren't the right analogies. And with my postdoc, George Hagstrom, we've been trying to resolve this paradox. This is a paper that has just come out in a book edited by Miguel Centeno and others called How Worlds Collapse. And basically, I'm not going to get into this deeply here. We have been focusing rather than on phase transitions as viewed in physics on, but first and second order, but on what are called spinodal instabilities, where there be two basins of attraction and an external field, and we could get a first order transition that would show these early warning signals. And we've also been interested in thinking about dimensional reduction as an early warning indicator, and looking at correlations in financial markets, housing markets, etc. So the importance of critical transitions, whatever the way we look for early warning signals, raises important management challenges. And that's the last part of my lecture before I open this up for lots of discussion, I hope. And that is, how do we achieve cooperation and collective intelligence, given that when you have individual agents and you have a social collection, the social optimum may not be easily achievable, just like in the prisoner's dilemma, because individuals don't cooperate but see their own selfish short-term interests. This takes us into thinking about public goods problems, which I think are the great challenge in achieving a sustainable environment. Public goods problems are widespread in both socioeconomic and ecological contexts, whether the situation on the left, where we see fishermen sharing a fishing ground and oil rigs offshore, or whether we're looking at the biological example, where we have tumor cells which are growing at their own short-term benefit, ultimately at the harm of the host organism, and wondering whether we aren't, in fact, the tumor cells undermining the persistence and sustainability of the biosphere. Now, the notion of the commons and the problems of public goods were first introduced by William Forster Lloyd about 2 centuries ago, and undoubtedly one can find older references as well. But Lloyd used the term the commons, and then Garrett Hardin, pictured on the left, wrote a famous paper called The Tragedy of the Commons, in which he said the solution to these problems is mutual coercion, mutually agreed upon. But what he meant by that is that individuals would band together to create governments that would enforce behaviors that were in the collective good. That's not so easy to achieve. And Elinor Ostrom, another Nobel laureate in economics of a little more than 10 years ago, showed that in small societies, like among fisher people, the necessary mutual coercion could arise from the bottom up through the development of social norms that regulated behavior. So how do social norms of this sort become established? What's the role of leadership? How's consensus achieved in democratic societies when there's incomplete information about what others are going to do or what their other so-called outside options are? What's the role of people who are not strongly opinionated? With my former postdoc and then colleague in the department, Ian Cousin, who now directs a very successful Max Planck Institute, we began by exploring consensus in the movement patterns of animals. Ian's an expert on fish. We published early papers in 2005 on collective movements of animal populations, but then we continued to extend this with a lot of colleagues, many of whose names you'll recognize here, and looked at analogies to decision-making in human groups as well. And similar conclusions emerged from all these angles, whether we were doing, which means whether Ian was doing experimental studies with fish, or either simulation or analytical models of animal movement, or models of human collective decision-making, where we allowed individuals to be connected to each other on networks, interact with each other, influence each other, make decisions based on what individuals close to them in the network, or in a more sophisticated model, members of the same groups, and those groups could be overlapping. And on longer time scales, maybe the groups would change their norms, or individual would change their memberships in groups. In all of these models, we found similar conclusions. First of all, that unopinionated individuals were extremely important for aiding consensus. And just to give you one example from the paper, which we published in 2011 in Science, if you're interested, we looked at, and this is in the model, a situation in which there were two opinions. A majority of individuals had one opinion, a minority the second opinion, but what those numbers 0.3 and 0.38 mean there is that the minority individuals held their opinions much more strongly than the majority opinions. They're more stubborn. And so that had the interesting consequence of, if there are no unopinionated individuals, then the minority viewpoint could prevail. If you add, and that what I'm showing here, if you add uninformed individuals, and on the vertical axis, look at the probability in this network that the majority of viewpoint will be reached, even though it's more weakly held, what you see is that if there are no uninformed individuals, that probability with these numbers was about 0.6. But if you increase the number of uninformed individuals, or unopinionated, I should say, then that favors consensus towards the majority viewpoint. Not surprisingly, if you increase the number of uninformed individuals without bound, you will ultimately get to a situation close to 50-50, where the opinionated individuals are just swamped out. But it's a very interesting set of parameters to be able to explore. Okay, so conclusions to this date is that public goods and common pool resource problems represent fundamental challenges in economics and in evolutionary biology, that collective action is possible. It can emerge from local interactions, that systems, sorry, it's some reason jumped over that, that the dynamics are played out as Jacob argued, on multiple scales, but that the collective decisions can impose the multiple coercion, the mutual coercion mutually agreed upon. And if we want to understand the management of the commons, we have to link these together. But ultimately, the conclusion is that we need cooperation and collective intelligence. Naomi Leonard, my close colleague, and I wrote a paper in the inaugural issue of the new journal Collective Intelligence, pointing out that collective intelligence is a public good. And we explore the way it arises. Naomi's a control engineer, so we worked a lot on distributed robots put out in the field. But unfortunately, despite the fact that we need a collective intelligence, political polarization is on the increase and threatens democratic governance. Now, the next few slides are very US perspective, but the same ideas could be applied to almost any of the countries represented on this call, and also to the equivalent of it at the international level. The Pew Foundation, the Pew Research Center in about 10 years ago, 9 actually, published a book on political polarization in the American public, and looked at what had happened between 1994 and 2014 along a left-right axis, showing how Democrat and Republican individuals had moved apart. And in fact, updated in 2017 to show that that split was even greater. And if you looked at what are called the elites, namely congressional leaders, this split is dramatically demonstrated. I thank Eve Lelks for producing this for me. But you can see that the parties are moving apart, that the Republican Party has moved more dramatically away from the center. That won't surprise anybody, I don't think. And so this led us to organize a special issue of PNAS, which I did together with Helen Milner and Charles Perrings, and some help from Bob Axelrod. If you're interested at all in this topic, I think you'll find a lot of interesting papers in there. In particular, this one led by Naomi and with a number of political scientists as collaborators, and edited by Bob Axelrod, showing how the interaction between polarization in the populace and polarization among the elites, how there was coevolution between them, neither one solely driving the other, and leading to the sort of asymmetric political polarization that we are increasingly seeing in the US and in many other countries. So what does this all mean for where I started? Scientific consensus is strong on many core environmental issues like climate change, but we haven't taken adequate action to address them because the primary limitations are not that we don't know what to do scientifically, but rather the willingness of people and governments to commit to the common good and to cooperate in finding solutions that benefit everyone. This is a now somewhat dated study, but I don't think things have changed much. If you look at attitudes towards climate change, and this is a Resources for the Future study, whether you ask whether people believe there's an increase in temperature or whether it's humans are responsible, whether we should do anything about it, whether we can do anything about it, no matter which box you look in, you'll see similar results. In China and Sweden, with very different sorts of government structure, an overwhelming majority, 95% plus or minus one, believe that it's humans that are responsible. The US has a majority, but only 73%. So why should this be? What's the role of the societies we live in? What's the role of social norms? In the US, also, we saw that in 2008, about 51% of the people were either alarmed or concerned about climate change. That had dropped to about 39% in 2010, possibly to some extent because of the financial crisis that turned people's attention to short-term solutions. By 2016, it was back almost up to where it was in 2008, and today it's about back up to where it was. Similarly, if you look at mask wearing, and we have lots of countries represented here today, anybody who's traveled in the Far East or lives in the Far East knows that in China and Hong Kong and Taiwan and Japan, mask wearing during epidemics has always been a custom, and not surprisingly, people wore masks during the COVID pandemic. In the Nordic countries, there was never a tradition, and there was no transition. But then in a large number of other countries, like the United States and many Western European countries and Canada, mask wearing was never common during flu season, for example, but during COVID, there was a transition like this, and I and many of my colleagues still going into crowded settings wear masks. So we're published several papers trying to understand the coevolution of the dynamics of epidemics and the dynamics of the social norms by which people decide whether they should be wearing masks or not. Social norms are key. This is a paper that we published some years ago, that social norms are both a problem and a solution to the problems. And Paul Ehrlich and I wrote a paper in 2005 arguing about the importance of norms. The most famous example, foot binding, which went through a rapid transition in China, and that norms could change rapidly, and maybe, and as I showed you, changing towards climate change and changing during the pandemic. Lynn Ostrom, just in some closing remarks, in some of her last work before her untimely passing, argued for what she called a polycentric approach for coping with climate change. Namely, you create small nexi, I guess that's the plural, nexus of cooperation, and they become building blocks, because 200 countries are not likely to agree on climate change, but smaller agreements can be developed, and then those can be used as building blocks to global agreement. And so with my student, Dave's his father, Andrew Tillman, and the economist Avinash Dixit, we published a paper in Theoretical Ecology exploring this. I won't take you through the math, there's no time for that, but we broke the population up into the groups and explored other topologies. Within each one, every individual, this is the utility function for individual I in group G. There's some payoff function right at the beginning, Y, which depends upon your investment or that individual's investment in its own private interest and whatever the public good is. Individuals can either contribute, save the money for themselves, or contribute to the public good. There's a cost of your total effort. And then there's a term that represents how much you care about other individuals in your group. I won't take you through any more of the math, but the idea here is to view this as a game theoretic problem in which X and Z are the variables. How much do you save for yourself? How much do you contribute to the public good? How much do you, because there's this cost function, how much do you not spend on either one? I'm going to skip over this, but not surprisingly, what we showed is that prosociality, caring for others, at least in your group, facilitates cooperation, that local prosociality with benefits that leak out to others. Now, what does that mean? That means if Sweden controls its pollution, that's a benefit not only to Sweden, but also to Norway and Denmark and other countries because of the leakage of that benefit of clean air. That local prosociality can lead to global cooperation. And then with Avinash Dixit, although I haven't taken you through that paper, showed that prosociality can be selected for because it leaves its offspring with better life. I will show you that and then quit. Why prosociality should exist is a problem that's been around for a quarter century. Well, it's really been around longer if you can go back to Charles Darwin, but Herb Gintis raised this in his 2001 paper. Why do selfish agents not drive out altruistic behavior? In the case of the work that Dixit and I did, the argument is basically a pro-social world is a better place to live. We want our children to be in a better world, and therefore we're willing to make investments now, for example, in education systems to create a more pro-social world. And we showed mathematically, therefore, how pro-sociality could arise. And that's in this paper. And any of these papers I'm happy to send to anyone which disappeared in a book. So to conclude, I've tried to show that at all levels, mathematical thinking can address the fundamental problems of complex adaptive systems, emergence, the robustness, and ultimately the conflicts that are engaged in trying to maintain the global commons. that unifying disciplines and transferring successes in one discipline to another can be a very powerful tool. And this, I would argue, if Ed Wilson were still alive, would argue to him, was really what he was talking about when he was talking about consilience. It's what our National Science Foundation calls convergence research. So I suspect this is a very interdisciplinary audience, and I'm looking forward. Thank you for listening. I'm looking forward to any comments. Thank you.
Thank you so much, Simon, for this great talk. And if you have any questions, please raise your hand in the participant list and I will call on you.
Geza.
Yes, Geza.
So the tragedy of common framework essentially assume individuals which are essentially the same kind of people. But in the global warming discussion, the difficulty is that the rich countries and the poor countries are in a very, very different position, and poor countries tend to ask the rich countries to decrease the emission first, while the rich countries want to say that all of us will has to decrease the emission. And my question is whether this kind of essential asymmetry between the participant and the tragedy of commons in such an environment, whether it is investigated or not, or what is the status of this?
So several points. First of all, good points. Because of the shortage of time, I talked about the tragedy of the commons and related it to prisoner's dilemma. Many of the problems we're dealing with in a game theoretic sense are not prisoner's dilemma. They're coordination games in which there are multiple equilibria, and the challenge is to get from a less socially optimum equilibrium to a better one. And Scott Barrett and Astrid Dannenberg in their work have explored that in fascinating ways, and the fact that individuals given the choice often will choose to play the tragedies of the commons, even though because they're tempted by the higher payoff and they never get there. But that's sort of a side point. The point you raise about asymmetries is crucial, obviously. In work with them, led by George Pacheco, we've explored some of that in terms of wealth distributions. There's no reason, obviously, in a game theoretic sense, you can't consider asymmetry of payoffs, but you're absolutely right. It makes things much harder, and it also suggests that the solutions to these problems are ultimately going to require some sort of side payments of more wealthier countries and ones that have already reaped the benefits of growth, and poorer countries. So those are extremely important issues that you raise that need to be explored. A related issue that we've been working on has to do with the distribution of vaccines during COVID, for example. Countries that have them have the challenge there of do we save everything for what we got at home, or do we ship it to countries that don't have their own vaccines or don't have good vaccines and need them? And there the problem is complicated, of course, by the fact that even from a selfish point of view, if you keep your vaccines at home, then then new variants are going to rise in other countries and come back and get you anyway. And to some extent, that's true in climate change and things of that sort. But but as you point out, there are asymmetries in the system that need to be considered in terms of the economic well-being of various countries, et cetera.
Thank you so much. Are there any other questions? Comments? While people are thinking, maybe I will ask something.
Yeah.
So, unfortunately, I don't remember which Richard Levin's paper that was, but he does have a paper where he wrote in his style a very simple little model to look at how consensus is reached. And the point he was trying to make is that if there are two sides to a debate and they're very invested in doing whatever to get their way through, then one can get a dynamical situation where the truth oscillates. Well, not the truth, the consensus oscillates back and forth. And I'm wondering, you were showing some of these graphs with fraction of unopinionated people versus majority and minority opinion. Do you actually see this kind of behavior?
So actually, if let me back up a little bit to say that in the early stages of theoretical ecology, I read almost everything I could from Dick Levin's because I found it very stimulating. The paper you're talking about is not familiar to me, so if you can find that reference, I'd love to see
Let
it.
me make a note. I think it's a more recent one, 2000s, and it's in a philosophy journal, so that's why it might have obscure. But I'll find it. Maybe it's 2006. I'll look.
Thank you. But going back, so in the work that I did with Ian Cousin, and Ian was very much the leader in it, we looked at what happens if so I don't think this is necessarily the mechanism that Levin's was talking about, but we looked at what happens if you have let's say a small number of leaders who want to go towards target A and a small number of leaders who want to go during target B, and most of the population made up of individuals who are followers. And the model has a stochastic element in it, which is important here. And under some conditions, what we found happened was that the group as a whole would move with consensus towards the mean between the two, and at some point has to make a decision and goes towards one target or the other. However, once it reaches one of those targets, it then moves back to the other target and back and forth and back and forth. And the reason for that is that because this is a stochastic model, as you get up near the target A, we'll say, and then individuals are surrounding it and their arrows are pointing towards it, none of their arrows are pointing in the same direction because they're distributed around, whereas all the individuals who want to go to the other target are more or less pointing in that direction. And so suddenly there's a transition that goes to, and the way I view that by analogy is thinking about our political parties. If one political party gains control, then at some point, the infighting within that party becomes more important than the fighting with the other party. And that leads to the movement in the other direction. And we certainly see that in the United States, in our parties. And I think you see it in the UK system. I can't comment on other governments, but Finland seems to have just gone through such a transition as well. Sweden too.
Sweden, that we just had a change of government.
Okay, so I do think that there is a tendency to do that under certain conditions, because basically for the reason that once you get consensus in one goal, then within that, then the integrity of the group becomes weaker. You don't need the group as much, and you rather control the group within. So, I'd love to see what Levin's wrote on that. I've never seen that. I didn't see that paper, and I've never seen it cited in any of the political polarization literature.
I'll find it for you. And thank you very much for that answer.
Yes.
And oh, Liz, please go ahead.
Hi, it was very nice to listen to you. I have a quite general problem, and I'm very interested in your opinion about that. That the economy, macroeconomy, somehow is missing from the approaches, and somehow I feel that very strong driving forces missing, and I try to explain what I mean. The global crisis and the crisis, let's say, on the Galapagos, approached by the same dynamic system approach with with recommendations, what should be done. Okay, so it's clearly what should be done. The number of the tourists should be decreased, kept under a minimum, and it was suggested that let's say in 2009 in Environment and Society, in this journal, with not an explicit dynamic model, but with a flow chart showing what effect what in the model. But of course, over the next 10 years, the number of tourists just doubled, okay? Because there is a very strong economic force which drives the process. And we are biologists, and we look at how animals behave. And we forget about that we are such type of animals who created economy and who created a capitalist economy with long-term trends and processes. So why economy is so obviously missing from the general picture? What do you think about that? I also read the white paper made for the Nobel Prize Summit, okay, where you were one of the authors as well. So it is the same again, the same conceptual constructions, and telling the truth. Looking at the example of the Galapagos, I just say that it's not enough. But I don't know the solutions, and yeah.
Well,
enough for a start.
I agree with you on everything, except I'm not entirely sure what you mean when you say that the macroeconomics has been left out. Let me give you a couple of examples which raise the problem. So the two examples I'll give you is that Ken Arrow, one of the greatest economists of all time, and Paul Ehrlich and I wrote a paper in, I think, 2014, but it may have been 2016, it doesn't matter, which said that ecosystems and economic systems are parallel and coupled complex adaptive systems, and raised a lot of the issues that I've been talking about now. And Partha Dasgupta, another great economist, and I had a paper that came out in the last few weeks in one of the Royal Society journals on the economics of biodiversity loss and what's been wrong with the economics. So you may be interested in that paper. Since it just came out, you probably haven't seen it, and what some of the fixes will be. But I fully agree. I mean, that individuals are, because they discount the future and they discount the interests of others, and maybe they even discount their own long-term interests, take actions in the short term that makes us, like, that's why I started with the tumor cells, which undercuts the long-term sustainability of the system for our children and our grandchildren, and that we've got to find a way to get the collective intelligence to go beyond that. So it may be that I don't know whether you were saying that in a lot of the models, the macroeconomic picture is not included, or in the way that decisions are made. If it's the latter, I fully agree with you, and it may be true with regard to most efforts to include economics in models of sustainability. But there's certainly efforts. Arrow argued, he said the reason that markets don't work to deal with, and I think we said this in the paper, to deal with the public goods issues and the commons issues, is because the social costs of individual actions are not incorporated in the models, and so that we've got to take actions to close the system up. I don't know whether I've answered, but I agree with you.
I didn't want to say that there are no models. I just I have this feeling that that something is missing when we are thinking about that. How people opinion will be changed on something, how they cooperate, how they influence each other's decisions, and then the conditions are set up by perhaps set up by the economy.
Yeah, well, I mean, I think you're absolutely right that we ought to be turning attention a lot to opinion dynamics and how they spread and how they're important in these. And I'd be happy to send you some papers where we've tried to do that, but we haven't done much. There's lots more to do. So thank you.
Thank you.
Thank you very much. Any other questions? Well, people are
Yeah, I had one. I don't know if you can, I don't know how to flag you.
Oh, yeah. Please go ahead.
This is from US, and the thing that strikes me, if as we say, the world is getting so much more complex in terms of complex ecological, sociological systems, and I wonder if anybody has asked, and yet so much of the public seems so uninformed or uninterested in the complexity of these, of the whole system. And so has anybody asked about how solutions, whether solutions are possible if you look at, or simulate having different degrees of understanding of the system? So if you had like 20% of the people only 20% understand, what's the chance of getting cooperation and solutions versus if you have 50%, something like that? Thank you.
Yeah,
really
I first of all, I think you'd find a lot of the papers in this issue on political polarization interesting, because in that we explore, when I say we, I mean the authors of the individual papers. I'm not on all the papers. Things like the role of social media, the role of and this is and the role of echo chambers in which people. The situation's gotten worse, where people on the left in the U.S. will only watch MSNBC, and people on the right will only watch Fox News or things more extreme than Fox News, and that this just increases polarization. And I'm sure you follow the same news stories I do, and you wonder, how can people believe what they believe under these situations? So obviously there's work on it, not so much from a modeling point of view, but there is some modeling that's in this special issue, and also there are interesting studies from psychology showing the weakness of classical game theoretic arguments, in that in the sense that when people take actions, they make the assumption that other people in their group, if they're operating in a small group, are using the same sorts of rules of thumb that they do. For example, might have the same degree of prosociality or the same degree of caring about the collective good, but that can mean a lot or it can mean a little caring about the collective good, and I think that's driving a lot of polarization in terms of essentially libertarian versus universalist points of view. When I talk about mask wearing or vaccination in a lecture I give on COVID, I show a picture of an old guy my age driving a car and saying, I'm not going to use turn signals when I'm driving. It's nobody's business where I'm going. And the same argument can be made for concerns about the long-term future of the planet, the effects. I mean, you know that people are unwilling to accept conclusions about climate change, biodiversity loss, COVID, etc. And some of that's on both sides of the aisle. And I'm sure you just look at these and think, how can that be? How can they not see what's right in front of them? But they don't. I don't think it's been explored a lot from the modeling point of view, but it's certainly explored among psychologists and sociologists.
Thank you so much. Are there any more questions or comments? Yeah, Geza, please go ahead.
I am one of the other very polarized country, and my impression is that I think that there is a kind of general trust level in the society, and the lowering of this general trust level leads to such kind of things that we don't believe science, we believe conspiracy theories, and for me, if I consider science is opinion A and the conspiracy theory is opinion B, it is something wrong with it. So somehow people lost their possibilities of knowing the truth, or I don't know how to explain, but what do you think about?
Yeah, well, I mean, there's no question that one of the great problems that's been developing, and in the U.S. at least, and I imagine other places, the pandemic exacerbated the problem, is the lack of trust in science. You know, there have always been groups that didn't accept scientific views on evolution, more recently on climate change, and nonetheless, I found it shocking to the degree to which, for example, Anthony Fauci here, who is a hero of mine, became one of the villains. And I think it's associated with, if you read the literature on polarization, people who study political polarization talk about two kinds of polarization. One, which would be, call it ideological or issue polarization, meaning you and I disagree on an issue and different points of view can form. But the other, which I think is, and I think to some extent that's good because it helps clarify issues, but there's another phenomenon called affective polarization, which co-evolves with ideological polarization. And affective polarization means if you have a different view than mine, then I hate you. And if you tell me something, I'm not going to believe it. And this just increases the degree of polarization. And anybody who reads the papers, at least in the US, but I know in other countries as well, will know that the degree of affective polarization seems to be increasing, just villainizing anybody who's got the opposite points of view. And political parties, and one of the papers I didn't have time to talk about is a paper on the role of political parties, something that James Madison, one of the founders of our Constitution, hoped to avoid and failed because he thought political parties would be polarizing. And indeed, if you have a heterodox view within with regard to your political party, then you get ostracized, you get censured for any action that's outside. So these are methods to enforce the allegiance to a particular set of views. So I think all of that has led to the demonization of science, whether it's the so-called radical left on climate change, or on the fact that the pandemic was going to be a big problem, has been a big problem, that we needed to do something about it. One of our great challenges is going to be to try to restore faith in science, and I don't know whether that's possible or not.
Thank you, Simon. Are there any more questions? While people are thinking, you might see in the chat, I linked in the paper.
Yes, I've made a screenshot of that, so I've saved that.
Any more questions?
There's a question that just appeared in the chat.
Please go ahead. Yeah, please.
Maybe I can't see. Oh, wait a minute.
Sorry. So I let's get back to my favorite topic. Here, I am watching MSNBC and also look at Fox News sometimes. And this polarization is also created by people who makes money from these polarizations and who would like to keep their audience. And so it means that economy and capital is also behind these processes. The other thing that I don't know, what do you think about the Meadows report, the first world model, and from the Rome Club report from 1972. And their predictions was that the catastrophic, the catastrophe can be avoided if education and health will be supported. And education and health are underfinanced in all of those countries. What about I know? Perhaps others in the audience have other experience, but these are public goods and somehow they don't seem to work. So it means that, again, I think that this is a clear example that you cannot leave out from neither from the models, neither from the general thinking capitalist economy. It's just creates situations and then you start to think that how to solve these problems by learning about human behavior and how humans, etc., affect each other and so on, based on animal examples. It's a real problem for me. So it's please.
Yeah, I mean, I don't disagree with anything you said, but I mean, the Meadows report, somewhat old now. I mentioned the work that Dixon and I did, showing that education could be used to foster prosociality. But I will also point out that the weakness of arguing that we need education is that in a polarized society, there's a lot of debate as to what education means. We're seeing that increasingly in the United States. where books are being burned, basically, where there are various school boards that are arguing that we need balanced education, that we have to balance science with religion, or that, you know, things
Yeah,
that
I agree. Yeah.
that we can't talk about past history if it makes people feel bad. So to say that education will be a solution to the problem is, as you know, a drastic oversimplification, because there's education on both sides, and some of it is actually creates problems. If we could all agree on education, maybe that would help. And I certainly believe that I mean, I've spent my life as an educator, so I certainly believe in what you're saying, but the system is being corrupted. And it's not just, I certainly believe there are people making money off of this. You know, people that you see as talking heads on television, and maybe even people who become president, who don't believe what they say, but say it because it allows them to stay in power. They're educated, but they've been diverted by the economics. And there are others who are just educated in a certain way, and their beliefs are inconsistent with other people's beliefs. So I'm all in favor of education. I don't think it's a simple solution to the problems. I see that Fernanda has a question. I'm not sure I can answer it. She asked me about whether I know Unzi Biggs. I do. Whether I know this paper, I don't. But the paper argues for integrating ecological and governance issues. That I certainly believe. We've written a number of things on that topic. We had a paper in Ecosystems last year. I was the first author, involving many of the people who collaborate with Unzi Biggs, talking about governance. It's titled "Governance in the Face of Extreme Events," what we can learn from evolution and how we have to go about it. So if Fernando, if you'll drop me a note, I'll send you a copy of that paper. I'm not sure it answers the question of how much polycentric. I think that's a very good question, and I think you say you're an applied math student. I guess that means a graduate student, and I think that's would be a good thesis topic to explore variance governance structures. I consult for the Boston Consulting Group, and we're looking at questions exactly like that for how you run a company or a corporation. How much top down, how much bottom up. So those are fundamentally interesting questions.
Thanks so much.
I have another quick question.
Go.
Has Tim Snyder at Yale has written about tyranny. Has anybody ever asked questions about democratic institutions and critical transitions to autocracy? In terms
sure.
of,
yeah,
they have, okay.
But I don't think I can.
That's fine. I can find it, but it seems like an obvious kind of question.
Yeah,
fragile stability there.
Right. So I mean, that's an interesting question. I don't know that literature, and we wrote a paper some years ago called femto. It was in I can't remember if it was in Science or the Proceedings of the National Academy of Sciences, called femto risks, in which small events could lead to sudden transitions in governance systems. The first author on that is someone named Aaron Frank. So you can find it if you look at Aaron Frank and femto risks. But that lays out some of the problems, but it's not a modeling framework where we've looked at critical transitions to autocracy. So I don't know. That's an interesting question. If you find an answer to that, please let me know.
Please let us all know.
Yeah, right.
Any other comments, questions? If not, then thank you so much again, Simon, for coming and speaking here. And thank you all for coming. I believe this is the last seminar of this semester, so we will be back sometime in the fall and we'll be in touch about when and who will be the speakers. I don't know, Geza, if you wanted to make any announcements about that, but I think that
Not more. See you in September, maybe with Hanna Kokol. This is not sure, but they will continue.
Yes, exactly. We're hoping it will be.
Thank you. It's a great series. Thanks very much for inviting me.
Thank you so much for coming.
Thank you.
Thank you, and bye, everyone. Bye.
Bye.